Hello, my name is Raguraman Hari. My final project is on student attendance risk prediction as part of the AI Product Management Specialization at Duke University. Course 3. In this presentation, I'll walk through the tasks analysis, user experience design, privacy consideration, and ethical conclusion. Let's begin with task analysis. Students often start reducing attendance gradually, but teachers notice it only after some time. By then, it leads to disengagement, poor performance, and even dropouts. To solve this, our task is to use attendance logs to detect early warning signs like consecutive absences or sudden drops in attendance. The model will classify students into low, medium, or high-risk categories and provide timely alerts to teachers. The development flow begins with collecting and processing attendance data, selecting key features, and training the model before deployment. In real time, the model takes attendance feeds, predicts risk, flags at-risk students, and enables teachers to act while we continue monitoring. This simplifies the process by automating monitoring, showing a prioritized list of at-risk students, and providing one-click interventions like reminders or parent calls. Here's how the user experience looks. Teachers get a dashboard that displays student name, class, last attendance date, their risk percentage, the confidence score, and a suggested action. For example, Naruto is flagged with a 75% risk, high confidence, and the suggested action is to call the parent. Hinata, on the other hand, is at 40% risk with low confidence, so the suggestion is to monitor closely. Teachers can review these predictions, confirm or correct them, and log any interventions. Students don't need to provide any input since attendance is auto-captured, while admins oversee system roles and performance. The model also highlights the drivers behind a prediction, like 2 consecutive absences or attendance below 60% this month. Uncertainty is communicated using bands: low, medium, and high risk, supported with color coding. For borderline cases, the system flags them as monitor closely. Privacy is a very important aspect of this project since we are dealing with student data. The system uses personally identifiable information such as student IDs, classes, and attendance logs. We avoid overcollection by not storing sensitive details like health, caste, or religion. There's also a transparency risk if families are not made aware of how this data is used. From a compliance perspective, India's Digital Personal Data Protection Act requires consent, clear purpose limitation, retention policies, and grievance redressal. For any international students, GDPR also applies, ensuring rights like access, correction, deletion, and portability. To stay compliant, we only collect the minimum required data, encrypt and restrict access through role-based controls, and retain data only for the academic year. Families are also clearly informed that the data is used strictly for support, not punishment. Finally, let's look at ethical considerations. Bias can occur in several ways. For example, students from rural areas with poor internet connectivity may be underrepresented. Smaller schools with incomplete digital records may face representation bias, and online attendance measures like logins may not perfectly reflect real presence. Even teacher feedback can sometimes create inconsistencies. To ensure fairness, we audit model accuracy across gender, socioeconomic groups, and school types. For accountability, teachers always make the final decision, while the AI serves only as an advisory system. We also keep logs for review. Transparency is maintained by giving clear explanations such as 3 absences in 5 days leading to high risk, and we publish a model card documenting purpose, data, and limitations. The model is retrained every semester, monitored for drift, and regular bias and fairness reports are published to maintain trust. Thank you.